So in this video, we're going to be looking at the multiplication and division of surds. So we'll start by looking at the multiplication of surds. So what I've got boxed here and written in purple is basically the generic rule you can follow when you are multiplying or dividing surds. So in the first part, I've written root x times root y is equal to root xy. So basically here, when multiplying surds, we multiply the expression under the root sign together. Or multiply the expressions, sorry. So this means, where possible, simplify your surd before multiplying them. It's not a must that you have to do this, but it will make it easier to simplify the surd later. Don't forget that the coefficients are multiplied together and then the surd is multiplied together. So again, I've written another rule down below where I've written a times root x times b root y is equal to ab root xy. So hopefully you can follow along with that. With what I've just said above in the theory with the rule there. So if we take a look at the worked examples, we're asked to multiply the following surds and express the answers in their most simplest form. So looking at question 4, for example, we can't really simplify the roots any further. So what we can do now is basically follow the law of multiplication of surds, or the rule, and basically multiply our coefficients together, which 2 times 5 will give me 10. And then multiply my roots together, which would give me root 30. Now, when we're looking at our new surd, especially the root 30 bit, always just have a quick assessment on whether or not that is the simplest form of the surd. So if it can be simplified further, please do so. If it can't, then you leave it like that. Having done a bit of pre-work, I know that 10 root 30 is our simplest surd, so I'm going to leave that as my final answer. If you're never not sure, it's always helpful to just type it into your calculator real quick and have a quick assessment. So we'll do that now, just so you can get comfortable with doing it on your CAS. So if we do 2 root 5, 2 root 5, again move your arrow out, times 5. And the reason I said move your arrow out is because otherwise it will extend your surd and you will actually be typing in a different expression into your calculator than what you've been asked. So our answer here is 10 root 30, which is exactly what we worked out. So we know we're correct. So let's take a look at it, question number 5. So here we've got 3 root 12 times 2 root 2. Now there's 2 ways you can approach this particular question. You can either simplify root 12 and make it a surd in its most simplest form, or you can simplify this whole expression first and then go on and simplify the surd later on. So we'll do both strategies so you can sort of understand what I mean. So if we do what we've been encouraged to do, which is to simplify the surd before multiplying it, let's simplify 3 root 12. So we know that that is the same as saying 3 root 4 times root 3, and I'm just going to write the rest of the surd. The rest of the expression. So now simplifying this here, I'm going to get 3 times 2 root 3 times 2 root 2. So simplifying this further now, we're going to get 6 root 3 times 2 root 2, which is then going to give me an answer of 12 root 6. So looking at this now, I know I can't simplify root 6 any further, so I'm going to leave it like that. So my final answer is going to be 12 root 6. Now, the other way you can do this question is by following the first rule, which is root x times root y equals root xy, and then simplify your final answer from there. So let's have a go at doing that. So this is option 1. Option 2 is to go, all right, so 3 times 2 is 6. And then root 24, so that's 12 times 2. So we know here we can simplify this further. Again, identifying 2 factors where one is a perfect square. I'm going to write 6 root 4 times root 6. And then if I simplify that further as well, so 6 times 2 times root 6, that's going to give me an answer of 12 root 6. So either or method is obviously going to give us the same answer. It just depends on what method you're most comfortable doing. The reason we do encourage you to simplify the surd at the start is just so you get more practice in simplifying it, especially when it's smaller, because it does become quite difficult to simplify larger numbers that are surds, just because there's a few more steps involved, or identifying the factors becomes a little bit more cumbersome. That's not to say it's wrong, it's just personal preference at the end of it. All right, and then our last question here is root 9x to the power of 5 times y to the power of 2 times root 5xy. So my suggestion here is to actually simplify or extend, I guess, the expression under the root. So what I mean by that is actually so I'm talking specifically about the first part of this, is to write root 9 times x to the power of 4 times x times y to the power of 2 times 5xy. So now that I've done that, it makes it a little bit easier to actually simplify this expression entirely. So root 9 we know simplifies to 3. And then if we take a look at x to the power of 4, and if we did a root or square root to that, remember that's the same as saying x to the power of 4 times by, or raised to the power of a half. So in multiplying this out, I actually get left with x squared. So then I'm going to do 3 times x squared, then root x times, and then again y to the power of 2, and then to the power of a half is the same as saying, well, I mean, when simplified, sorry, it's not the same as. When simplified, it becomes y. So I'm going to write times y. Then that's times root 5xy. So now simplifying this or rewriting this, I'm going to have 3x squared times y, root x times root 5xy. Again, simplifying this further, I'm going to have 3x squared y root. I'm going to do 5x squared y. So again, we know that if I had x to the power of 2 and I'm rewriting that root as a power, I'm going to have x. So that'll give me 3x squared y times x root 5y. Now remember, bases are the same for the x term, for the x's, so I can add the powers. So I'm going to have 3x to the power of 3 times y root 5y. And that'll be my final answer. So you can see that this particular question had a few more steps involved. Hopefully what you were able to realize is that we can rewrite the root sign as a power. Remember that there was that connection there made in an earlier task. So that's really important for you to do, especially when it comes to simplifying surds where there are variables involved. So hopefully now you're comfortable with multiplying surds. Again, surds is something that just comes with practice. So I do encourage you to continue practicing your surds, whether that be addition, subtraction, multiplication, or division, and that'll help you with being able to do these types of questions. So now looking at the division of surds, here I've put that it's really helpful to simplify them as much as possible before actually dividing them. So again, hopefully here you can see a reoccurring theme of simplify your surds where possible. Like I keep saying, it just makes the process so much easier later on, and it also means that you don't have to do extra steps later on. Obviously here the aim is to divide the coefficients first and then the surds as well. So the reason being that it just makes the process a lot simpler and a lot more straightforward. So here I've written root x divided by root y is the equivalent to writing x divided by y all under the root sign. So if we take a look at the first example, which is question 7, I've written root 28 divided by root 7. Now you can do a couple of things here. You can either choose to simplify root 28 first and then go on and divide, or what you can do is rewrite the fraction. So I'm going to choose the rewriting the fraction option just because I haven't given myself enough space to actually do any working out. So here what I'm going to do is rewrite the fraction using the rule root x divided by root y is equivalent to x divided by y under the root sign. So I'm going to rewrite this as 28 as my numerator, 7 as my denominator, all under the root sign. And that's going to be equal to root 4, which we know is equal to 2. So that's pretty straightforward. It's nice and easy. There's nothing much to it. And again, like I said, you can choose to also, I might actually just put an asterisk and do an alternative working out, which is actually simplify root 28, which will give me root 4 times root 7, all divided by root 7. And again, here we can simplify that, and that will leave me with root 4, which we know we can simplify to 2. Again, you can see here both working out methods were exactly read the same answer. So it's just depending on which strategy you prefer. So I'm just trying to give you a toolkit of strategies to employ. Obviously, as you learn your Surds skills, you become much faster at identifying factors, you get much faster at simplifying them. So at the end of it, it's just to give you an arsenal of resources or different methods and strategies you could use. So now if we take a look at question 8, I've got coefficients here of 9 and 3, and I've also got my surds. So what I'm going to do first is actually divide the coefficients out. So I'll be left with 3 goes into 9 3 times. Don't know why I had to pause that. And then I'm going to write 3, and I'm going to rewrite my fraction as 44 divided by 22, all under the root sign. So that's going to leave me with 3 root 11, and that'll be my final answer. So now looking at question 9, this one's a little bit trickier, so you do need to keep in mind that there are a few things happening in this particular question. The first thing I'm going to start doing is simplifying the numerator and the denominator, so just bear with me while I do this. So root 36 will simplify to 6, and that will leave us with root mn, and then root 9 is going to simplify to 3. And now I'm going to actually write my variables like this. So now I'm going to divide out my coefficients. Now, hopefully, when I did the multiplication of Surds task, it became quite obvious as to why I basically extended my variables or my terms out like this. So now it's making it easier for me to simplify them. So for example, if I've got m to the power of 6, I'm going to rewrite the surds. Instead of writing this, I'm actually going to rewrite that root as a power of a half. And that'll leave me with m to the power of 3. And then n to the power of 10. And then that's got a power of a half, so that'll simplify to n to the power of 5. So now rewriting this, so be very careful now because we've simplified that and we've simplified that. So I'm going to rewrite this now as 2 root mn divided by m to the power of 3, n to the power of 5, root mn. And now what you can see here is that we can actually, those divide out because they are, that goes into that once. So what my final answer will be is 2 divided by m to the power of 3 and n to the power of 5. So hopefully that wasn't too bad. What I would recommend you do is actually take care when you are dealing with expressions that look like that. What I would recommend is, where possible, if you can simplify them, definitely look at rewriting your root as an expression to the power of a half, because that'll make it a lot easier to simplify it. So you can see how I went from m to the power of 6, and that this is still telling us that it's square root. It's just an alternative way of writing it. So when I did that, it was a lot easier to deal with it. I was able to apply my index skills here to simplify that, and I was left with m to the power of 3. Same deal here with n to the power of 10 to a power of a half. That was able to nicely simplify to n to the power of 5. So hopefully by the end of this, you're feeling comfortable with using your division skills when dividing surds. Like I keep saying, it's really important to simplify your surds where possible. It just makes the whole process of answering the questions so much easier for yourself. Again, hopefully you can see, like in question 7, there isn't just one cut clear way to do it. There can be one or two other ways. So feel free to experiment with the different strategies. Obviously, with time, you become much faster at simplifying them.